Hey guys, welcome back to my channel Pharmacy with Preeti. So in today's video we'll be covering the analytical constant for fats and oils. Under this topic we'll be covering the following subtopics called acid value, saponification value, iodine value, acetyl value and ester value. So in this video I will be covering the acid value. Let's begin. So the definition for the acid value goes like this. It is the number of the milligrams of the potassium hydroxide which is required to neutralize the free fatty acids present in 1 gram of a substances. Now, what is the purpose for carrying out such test called acid value? Here, as we know, these oils and fats, it occurs in the form of triglycerides. Now, these triglycerides, when it is exposed to certain factors, it can be oxygen, light, enzymes, water, moisture. It will tend to undergo degradation or decomposition kind of reaction, leading to the formation of free fatty acids. And these free fatty acid is not good for health. So, the amount of free fatty acid can be determined by acid value. So the definition is the number of milligrams of KOH required to neutralize the free fatty acids present in 1 gram of a substance. Now these free fatty acids are acidic in nature. In order to determine these free fatty acids, we need to carry out the reaction with the potassium hydroxide, wherein we have to determine the amount of KOH required to neutralize the free fatty acids in order to determine the amount of free fatty acids which are formed during the degradation process in the substances. The principle for the acid value is, it is a titration kind of a reaction wherein the fats or oils are present as in a conical flask as an analyte, which is titrated against a 0.1 normal KOH or NaOH using phenolphthalein as an indicator. Now these fats and oils is dissolved in an alcoholic medium. Okay. Next is the determination method or the procedure. The following procedure is as per IP. Here we have to take a 10 gram of a substances. These 10 gram of a substances is taken into a conical flask and it is dissolved into a solvent, 50 ml of a solvent. Now this solvent is a mixture of 1:1 ratio ethanol and ether, which should be previously neutralized. So here 50 ml means we have to take a 25 ml of ethanol and 25 ml of ether to make a 50 ml of a solvent. And now why it is mentioned previously neutralized? The reason is these ethanol and ether may contain certain amount of the traces of the acids, which may bring a false result into the substances. In order to avoid the false result, it may this acid, the amount of acid present in the solvent may add on to the substance, which gives a false result. So in order to avoid such circumstances, we have to previously neutralize this solvent. So the neutralization of the solvent is carried out as the mixture of the solvent is taken into a conical flask and it is titrated against a 0.1 molar of KOH. As we know, this KOH is basic in nature. Here, this solvent which is taken into a conical flask, the phenolphthalein is added into it. So, in case if the solvent bears any sort of or traces of acids, it will turn into colorless as soon as we add phenolphthalein indicator. And as we further go on titrating with the potassium hydroxide, a point comes where this solvent containing the traces of free traces of free acids gets neutralized, which is indicated by the pink color. Once it gets converted into the pink color, it is considered that now the solvent is completely neutralized and this solvent is ready for the further step. Now we have to take a 10 gram of a substances and add it to the previously neutralized solvent. Okay, we have to add 50 ml of previously neutralized solvent, and in case if the substance and solvent is undissolved, then we have to carry out additional step called as refluxing. Here approximately 15 to 20 minutes of refluxing is enough to dissolve this substance and the solvent. Now once it gets dissolved through refluxing, we have to titrate this substance solvent mixture against a 0.1 molar of potassium hydroxide using 1 ml of phenolphthalein as an indicator. So initially after adding phenolphthalein indicator, the substance or the sample will remain colorless, and as soon as we keep on titrating with the KOH, a point comes which the substance gets converted into the faint pink color. Okay, the substance gets converted into the faint pink color. So in this GIF you can see initially it was colorless, but as soon as we added one drop of KOH, it gets converted into the pink color. So we drop by drop we have to add a potassium hydroxide until it changes to faint pink color, indicating that the free fatty acid which is there in the substance, it is completely now neutralized. And now we have to note down the burette reading, that is the ml of KOH which is required to neutralize the free fatty acids in the substances. Okay, the amount of the ml of KOH which is required to neutralize the free fatty acids which is present in the substances, and that volume we have to substitute in this formula for acid value. So the formula is acid value is equal to 5.61 into N by W, where 5.61 is a constant value for potassium hydroxide and N indicates the number of ml of 0.1 molar KOH required to neutralize the free fatty acids, and W is the weight in grams of the substances, that is the how much quantity of the substance which we have taken during the titration step. One thing to note is here is now you must have a question that why we are taking a mixture of a solvent, that is ethanol and ether. Why don't we just go for only one solvent? The reason is this ethanol is aqueous solvent, so it can easily dissolve potassium hydroxide. However, this ether, in order to dissolve our substance, that is oils or fats, in order to dissolve it, we have to use the ether as a solvent. Okay, that is diethyl ether, and this is the reason why we take a 1:1 ratio of ethanol and ether as a solvent. Next is the significance of acid value. So this helps in determining the amount of free fatty acids in the sample or in the fats or oils which is formed due to the exposure of certain factors. The factors can be air, moisture, enzymes, okay, etc. We have seen the reaction of fats and oils. If you haven't watched my previous video, do watch it. Thank you.